Here we go. So question 23 is where we ended off, which deals with the hybridization of this Lewis structure. So I'm going to go back to my blank document just so I have more room to solve these problems, because there's not enough room on here. And I think this is kind of where I ended off. So we'll say today is what, May 5th. Don't have to listen to any more of that Star Wars crap. And here we go. So question 23. So we had this Lewis structure with germanium. Okay, and germanium is found in the same group as carbon. Well, hopefully you remember that in General Chemistry 1, when we talked about molecular geometry, we talked about what are called regions of electron geometry. So this germanium is surrounded by 3 regions of electron geometry, or 3 reds, if you will, right? A double bond counts as a region of electron geometry. A single bond counts, a triple bond counts, a lone pair counts, and an unpaired electron counts. So since we have the lone pair, a single bond, and a double bond, we have 3 regions of electron density. Well, if we take that one step further, we talked about the hybridization based on the number of reds, or regions of electron density. So when we have 2 regions of electron density, we have sp hybridization. When we have 3, we have sp2. When we have 4, we have sp3. When we have 5, we have sp3d. And when we have 6 regions of electron density, we have sp3d2, like that. And since we have the 3 regions of electron density, the germanium is sp2 hybridized. So sp2 hybridization in this case. All right, so we'll just write it here, sp2. All right, let's move on to question number 24. So question 24, and just give me a second here to open up my paper exam. Let's see, paper exam, question 24. And it just asks us, what is the correct Lewis structure for PF3? So Lewis structure of PF3. And while you're trying to draw that, I'm just going to get one more thing pulled up here for myself. So I try to get organized. Okay, where was I? All right, so we have to come up with a Lewis structure for phosphorus trifluoride. Well, we have a phosphorus, which is in group 5A. So it has a total of 5 valence electrons. So we have 5. Fluorine is a halogen. It has 7 valence electrons, and we have 3. So that's 21 plus 5. So that gives us a total of 26 valence electrons. So I'm going to go over this one kind of quickly, because hopefully you remember that fluorine always has 1 bond and 3 lone pairs. So we can start with our phosphorus in the middle. We put 1, 2, 3 bonds to fluorine, like that. And then that eats up a total of 24 electrons. So we remove those 24 electrons. We've got 2 left over. We put them on the phosphorus, like that. And that is B. There's the correct Lewis structure for phosphorus trifluoride. Next question, number 25, deals with strongest bonds. So it says which molecule has the strongest nitrogen-nitrogen bond. I'm not going to draw out the entire question, but in number 1, we have the nitrogen molecule, N2. In number 2, we have 2 nitrogens attached by a double bond. We have 2 methyl groups attached here, right? You remember that from organic chemistry. And then in 3, the nitrogens are only attached by a single bond, and then they each have 2 methyl groups attached. Well, hopefully you remember that when it comes to bond strength, and that's what they're asking us about here, is we have the strongest to the weakest bond, not weakest, the weakest, is that the triple bond is going to be the strongest, followed by the double bond, and then the single bond will be the weakest one, like that. And so the answer is The one that has the strongest bond will be number 1, right? The weakest one would be number 3. All right. Let's move on from there and talk about question number 26. So question number 26 deals with intermolecular forces, IMFs, right? What are the intermolecular forces? Well, some of them are things like hydrogen bonding, right? You need to know what hydrogen bonding is. If you need to review that concept, do that. If you don't remember what a dipole force is or what a London dispersion force is. So London, which is the same thing as a dispersion force, right? You need to know those different types of intermolecular forces. So it asks us what type of intermolecular forces are present in a sample of ethanol, which is C2H5OH. We can draw the Lewis structure like this for C2H5OH. Well, since we have an oxygen-hydrogen bond in the molecule, that means that it can participate in hydrogen bonding. Remember that the requirements for hydrogen bonding are to have either an oxygen-hydrogen bond, a nitrogen-hydrogen bond, or a fluorine-hydrogen bond. Next, we can include dispersion forces, because dispersion forces are present in all molecules. Because there's electrons in the molecule, the electrons can move around. And so let's say at an instant or a moment in time, all of the electrons are in one part of the molecule.